Hello everybody and welcome to another video of CS301, Social Implications of Computer Technology. And today we are going to be talking about evaluating and controlling those risks in technology. In specific, we're going to focus our discussion on four subtopics. We're going to talk about evaluating information that we get thanks to technology. We're going to briefly talk about the digital divide. And then from there, we're going to kind of look ahead into what the future of AI holds and what kind of risks are associated to that. And then we're going to kind of switch gears and talk about the risks of technology, but that's going to be focused more on in terms of today, of kind of the potential errors and failures that can happen when something goes wrong with technology. So let us begin. Let's start with the first one, evaluating information. And so a lot of us have, heard a couple of terms. If we have been, keeping up to date with current events, we've all heard of the term fake news, right? In fact, it's been sensationalized in the past few years because of certain people that use it. And while I am not here to criticize any news outlet out there, what I would like to say is something in relation to what we consider to be news. When we go and watch the news, there are different ways of getting the news. I mean, there's watching on TV, there's something like reading a newspaper, reading a website, and other things. And it has evolved with time. I mean, if you look back 100 years ago before we had TV, most people would get their news from two sources, paper, and once radio came out, radio news. Then we had television come out. So, actually even before television, they could also get their news from movie theaters. So you'd go to the movies and you'd watch a newsreel in front of a movie, which will cover some of the recent international events. From there, when television became more popular and everybody had access to television, then we started seeing news in the TV, TV news. And then from there, when the internet started coming out, that was another outlet where news could come out and more directly reach consumers in different ways. And up even today, something like magazines or newspapers are almost kind of going out of style now that we have the internet with news. However, the same problem that has happened even back in the day with newspapers and before, when news came with just word of mouth, is still going on today. And that is, of course, the term fake news. What we happen to mean with this is that at the end of the day, the news are written by humans. Or, well, I suppose nowadays you can get some computers to write some news. But the majority of the news are written by humans. And humans are in nature biased. It's very, very, very difficult for somebody to be objective and subjective and, keep from a bias. But that's okay. A certain bias is to be expected. However, that's not what we're really kind of wanting to emphasize on. It is possible that some people may use the news or some outlets may use the news to further an agenda that is beneficial to whoever supports the news. In certain countries that were very oppressive, they used news outlets as a way of strengthening their regimes by feeding what is a famous term known as propaganda. If you looked at World War II, Nazi Germany, and you try to look at some news on that, they obviously were trying to say that what they were doing was good, even though the rest of the world was like, yeah, no, that's not good. So at the end of the day, that's the risk that you get with news. Now, in the world that we live on today, news outlets are a business. Some of them are non-profit, but the majority of them are for-profit, which means that at the end of the day, they need to pay their bills. How do they get their bills paid? Well, they run advertisements. They might run specific stories that may advertise certain companies as well. But in the majority of the content, the news outlets out there, they try to make a journalistic pledge to not let themselves be biased or let themselves lie to the viewer in exchange of money. They say we're going to give the news straight, but yes, we are going to play these TV ads in the commercial breaks, or we're going to put these ads on our website next to the news article. Why is that the case? Because at the end of the day, they need to support themselves. They need to pay the salaries of all the people that make the news happen. Unfortunately, not everything is perfect like this. And what ends up happening, and we can see it all the time, if we, go watch a cool movie, about the gray line of somebody owns the news and they may choose not to criticize certain groups because they may be co-owners of the news. And so I'll try to think, because I can't think off the top of my head right now, but there's a lot of movies out there that kind of show these dilemmas where the editors of a certain newspaper would not allow them to post. I think Post rings a bell. It might have been the Washington Post. I don't know. I will post. I promise I will post the link on the description for some of these movies that I'm thinking about, which are based on true stories. That they would not post certain news because they would negatively affect people that were co-owners of that news station. And of course, this kind of gets into the gray line of whether this is something ethically correct or not. So at the end of the day, the news want to sell money, and they might get sensationalized because they want to sell their news so that they can get better advertisement. They can get better ratings in TV. And this whole sort of drama kind of goes into the web in the same way. Websites that want to be seen more because they get more ad revenue may be compelled to write more attractive headlines. And we get a very popular term that we hear all the time, or I suppose read all the time, which is called clickbait. And that's whenever you see a news article or a headline that has something very, very shocking and may be sensationalized, like if you go and open the here I got my phone, I'm going to open a news article. I got to go to a website that actually does these kind of things. So let's see. I don't really have news. I kind of limit to what I see where I don't get any sensationalized news. But, oh, here we go. So this is, for example, something that like that's sensationalist, right? So it might say like, you will never believe what this person wore to this party, or, this shop will never reopen again. List of shops that will never reopen again. Or things like, you will never believe what X person said or Y person did. Even if it's based on something true, it might be like, terrible story happens in New Zealand. You will, everybody, and then they put a picture of people screaming or things like that, and you go and click on the story, and the story was about somebody like was drunk driving and like ran over a stop sign, and that's it, or something. And so there's this sort of sensationalized thing that they want you to click. They give you a hint, but they don't tell you exactly what is happening because they want you to click on that. And so this brings me to what I want to mostly focus on, which is validating information. The power of the web is that it allows people to express themselves in ways that have never been able to be possible. We all know another concept of something saying going viral. When something goes viral, it means that it spreads like wildfire, or like a virus, I suppose, and everybody sees it. So somebody does something crazy, like maybe they do a cartwheel on top of an elephant, and on top of a plane, on top of in space or something, and it's such a crazy thing that people share it, and everybody sees it. And so this is what going viral means, and anything has the potential to go viral. And that means that what you say or do, if you post it on the internet, has the capability of reaching millions of people very quickly. This great power, with great power comes great responsibility. And this is what really applies here, because the problem is that while it's beautiful that a lot of people can read information uncensored because you can express yourself, it also means that a lot of misinformation, a lot of fake news, I suppose, can go out in the internet that it's unverified. Anybody, including myself and including all of you, can go, because we're all CS people, we know a little bit of coding, we can all go and create a website. You can go buy a domain, you can go and set up a hosting service, and then go download a template, tweak a little HTML here and there, a little CSS, JavaScript, and then bam, we got ourselves, maybe some SQL, we got ourselves a website, a news website. We can make it look extremely legitimate. But the fact of the matter is that we made it. And now we have a responsibility to not lie, to not give propaganda, to not give bias, because people may not know. You know, they might think it's a legitimate website, not that it's made up by a random person, right? But maybe that's what we want. We want it to look legitimate, but over there we're going to go ahead and try to sell our latest cryptocurrency or something. So that is the risk that people face today, and that is why evaluating information is so important, because there's a daunting amount of information on the web, and a lot of that information is not correct. From a researcher's perspective, you're all working on your term papers, I hope. Back in the day, if you wanted to get information on a certain topic, you'd go to a library and you would talk to a librarian. You would talk to a librarian who'd be like, well, I'm doing research on, let's say I'm doing research on machine learning with location data. And then the librarian would be like, well, okay, that has to do with data science and data analytics. So go and look at the 5th floor, 6th row, and you can check those books out. Or here, let me go and try to see some academic journals that have to do with data science. And, you know, you can read those and maybe find something relevant to your topic. They, of course, are people that are educated and know their way around a library. But more importantly, they're educated and know how to research. That is how it used to be back in the day. But that, of course, has been for the most part replaced by a search engine. Nowadays, if you need to find information, you go to a search engine and you Google it. Right? The term Google something, go Google it. Let me Google that for you. That's even a website. The problem is that websites are ranked by popularity and not by expert opinion. Whereas a librarian would be like, okay, if you want to read a relevant news journal, let me go ahead and give you Nature or Science to read. You know, they're not going to give you TMZ to get some research information, right? The problem is TMZ has maybe more popularity on the web than Science does or Nature does. And so those articles are going to come before the academic articles, which will bias you. And unfortunately, things that are popular may not always be things that are true. And so that's a danger. It's a big danger out there for researchers, but also for people looking for the truth and looking for news. Now, not everything is bad. One of the beauties of the internet is what is known as the wisdom of the crowd. As an example, and I just thought about this. I wish I thought about it before, because hopefully I remember what it's called. There's a restaurant rating system that's called something like Goodyear. Oh no, Goodyear. Michelin, that's what it is. Michelin. Let me make sure it is Michelin. See, I knew it had to do something with tires, and so in my head I was thinking Goodyear for some reason. But hey, that's a good mental association. So Michelin, and it's called the Michelin something like food rating, restaurant rating, Michelin's guide, the Michelin guide. There we go. So here's, and I'll post the link on the description to Wikipedia, but I actually read about this not too long ago. I knew what the Michelin guide was, but recently there was a news article about Burger King wanting to have a Michelin star rating of 1, and this kind of prompted me to read more about Michelin, and hey, it all worked out because I just remembered, and this is actually relevant. So Michelin is a series of guidebooks published by the French tire company. So they are actually made by the tire company. That's why I was thinking Goodyear in my head, but like legitimate tire company. And if I remember correctly, and again, I pretty much got this from Wikipedia when I read it back in the day, is that they were trying to encourage people to travel, to use cars. You know, because the thing is, people travel, they wear out their wheels or their tires, and then they have to replace them, right? So like, you know, if you sell tires, you sure as heck want to encourage people to drive so that the tires wear out and then they have to buy more. Plus, traveling is a really cool thing, so like, it was a kind of a win-win situation, right? You know, promote culture by traveling and then also make more money. So what they went ahead and said was, okay, you know, a lot of people, they don't like to travel because then they're like, I don't know where I'm going to go, where I'm going to go eat or where I'm going to go sleep. And so they came out with this guide called the Michelin Guide, where they basically would write like, okay, this is the cool places to go eat, you know, go eat here because like we've had people sit here and actually review it and be like, okay, this is like a nice place to eat. And something so simple as that kind of really grew because people really liked it. You know, they were like, oh wow, this rating system is cool because like I don't have to like basically kind of hope for the best that I don't end at like a horrifying eating spot. And so the Michelin Guide like grew, and with time it became more of like just a random rating system to like an actual prestige thing. So there was like a 1-star restaurant was like a very good restaurant, 2 stars was like excellent cooking, and 3 was like exceptional, worth a special journey. Like, okay, this restaurant is actually worth you going there just because of the food. Like, forget about going to see this cool castle. Like, actually just go for the food. And so the guy was coveted, and it really grew a lot, and it became up to today where it's like very like, oof, you know, like, ooh, very nice thing. Very fancy thing, you know, like Michelin star rated restaurants are like praised, right? And so for the longest time, this kind of thing happened for other, you know, for other industries, like whether it was hotels or I guess restaurants in this case, or traveling locations. I mean, it was an entire industry of like people going and reviewing places and giving recommendations for travelers to go to. Well, that will change with the internet, because now we don't need to trust these so-called experts, and I'm not saying they're not, but you know, we don't need to trust these so-called experts because we have the power of the crowd. We have the ability to have the people be the ones who can give honest ratings, because of course there was always a problem with corruption, right? There's always been a problem with corruption. You know, if you know that you're a food critic and you're going to go to a restaurant, if the restaurant finds out you're a food critic, you're going to be treated extra carefully, and you know, they're like, okay, make sure that critic's steak is like cooked to perfection and whatnot. So now, of course, the critics, what they do is they try to visit anonymously so that they don't get discovered and they don't get treated specially. But of course, that's hopefully what they should do. But there's always that one person who is like, by the way, I'm a food critic, just so they can get a free meal somewhere or things like that, right? So there's always like like anything else, there's corruption, right? I'm not saying like Michelin is like a corrupt industry by any means. In fact, I'm sure those are one of like the most prestigious and like legit people. But I'm just saying that it opens itself to corruption. That's not something that you can easily do when you have a crowd involved with this. So you might have people that are, of course, biased and reviewing themselves, but the power of the numbers is that one person that changes things will not change the outcome of something. And so when you do things like Yelp, TripAdvisor, Google reviews, these are reviews that people are putting by, you know, they're giving out ratings, and this allows people to see honest ratings by average Joes like them. And they don't have to worry about people biasing them, because they will take a huge amount. You know, if I'm going to go find a nice sushi place, I go look on Google Maps, and I'm like, okay, this place has 800 reviews and like a 4.8 rating, okay? I obviously assume that like really angry people are going to give negative votes, and also people that are like friends of the owner are going to get really positive votes. So I try to kind of take that into consideration and sort of read in between the lines, right? But if the overall average is really high, but not perfect, which is also a good sign, then I can believe it with more honesty. And so the wisdom of the crowd is a very, very powerful thing that we kind of have from the internet. The more people that participate, the more useful it is. And it's not just about food or ratings, but also about knowledge. One of the wonderful websites that that we have been blessed to have is Wikipedia. I mean, I've been linking you guys to Wikipedia, right? I was just going to give you the Wikipedia link to Michelin. Wikipedia is an encyclopedia that is done by volunteers, not for profit. It's a non-profit organization. Although it does definitely cost a lot of money to run, because they need the service to host. That's why they're always asking for donations, because they refuse to run ads. They refuse, because the moment you run ads, then you're trying to please the content for the ad people, so otherwise they won't show ads, which of course makes you run the same risk that news organizations run when they're giving out ads. You know, they want to raise their ratings, they want to get more traffic in their website, so they put more sensationalist things that may not be absolutely true. Now, that doesn't make Wikipedia be the perfect best of all everything. Because at the end of the day, those volunteers are not experts. Typically, the people that work on Wikipedia are educated and are experts in whatever they're editing, but not necessarily. And that causes some of the posts to be biased and not necessarily accurate. Because anybody can write. Most people do not, but anybody can write. And that's why if you go on a Wikipedia article, you can see on the top left it says article and talk. If you click on talk, you can see discussions that people have regarding suggested edits. Back in the day, anybody, in fact, I probably did it myself randomly. Anybody could go and edit an article and it would immediately update. Nowadays, some articles allow that, but the majority of them, you have to go through a process where you request an edit and multiple people have to agree with you, and there's a discussion that happens before the edit actually gets approved. If you just try to do an edit flat out by skipping that, it gets reversed. And so that system is very important because it does allow us to sort of give a peer review to any edit that may happen to avoid a potential bias or misinformation. And this happens a lot with things like political things, like for example, with an election or something, people from a different party may want to go and modify a certain candidate's profile to make them look negative or positive in an unrealistic way. And so Wikipedia has to be very careful about that because a lot of people trust Wikipedia and they will unfortunately believe everything they read as absolute truth when it's not. And so it's a certain responsibility of Wikipedia, even though it knows that it's run by volunteers and that at the end of the day, it's written by people that may not be experts. There's still a certain responsibility associated with that. They've gained this reputation of being a source of truth that now they have to maintain that and they have a responsibility to do that. And so at the end of the day, the wisdom of the crowd is useful, but it does have the same problems that anything does when you have a lot of people involved, which may be that there's always a chance of manipulation and there's always a chance that information may be wrong because, a lot of people can be wrong on one thing. At some point in time, most people thought the earth was flat. That didn't make it right. It has been proven that the earth is not flat. And most people now believe that that is the case, except for those certain edge cases, which I don't want to talk about. But at the end of the day, just because the majority believes something doesn't necessarily make it true. And that's another danger with something like wisdom of the crowd. So there's also, like I said, the problem with vulnerable viewers. Children especially. Children don't really know this whole dilemma with Wikipedia. So they go read on something on Wikipedia and they believe it. That's why at least when I was in school, they would tell me okay, when you're writing your research papers, you cannot cite Wikipedia as your source. If you want to cite Wikipedia, go and look in Wikipedia at what Wikipedia is citing and get to the primary source, read that, and then cite that. Because Wikipedia can be biased and can be wrong. You cannot be trusted as a primary source. And it is up to you as an individual to make sure that you're educated and evaluate the information and take everything with a grain of salt and always seek primary sources. Click Wikipedia. When they state something, they typically write a citation. They put little brackets with a number. Click on that number. Go see that primary source. Make sure that that's actually a legitimate source. So I think that's all I want to say about that. Okay, yeah, that's good enough. So now let's talk about the digital divide. So what I mean with digital divide is that today we have approximately 2 billion people with access to the internet, which is frankly at least a fivefold increase, over roughly a decade from what we had before. However, today 5 billion people do not have access to the internet. So 2 out of 7 have access, 5 out of 7 do not have access. And this is what's known as the digital divide, because we have new technologies that are only available to not necessarily wealthy, but to people that are better off. Not necessarily I'm not talking okay, this is only available to super rich people. I'm just saying that economics is a big factor as to why a lot of people don't have access to the internet. And usually it does take time for new technology to make its way into common use. So if you think about, for example, virtual reality. Virtual reality first came out long time ago, but like modern virtual reality, like Oculus stuff, that's pretty like nice virtual reality that came out recently. The cost of that was like $500-600 for a prototype system. I can't remember. I think I paid like a little bit more than that for the Vive. But then you also have to add in the computer that can run the virtual reality. So we're looking really at something over $1,000 to be able to run a VR set. With time, that has gone down. We have something like the Oculus Quest 2, which I think I paid like $500 for it, but there was a version that was a little bit cheaper. And at the end of the day, with time, that's going to go down in price. You look at things like smartphones and all the idea, all that type of technology. Back in the day, there was things like Palm Pros, and then the PSP was kind of like a really, really low-end smartphone because it had the capabilities of Wi-Fi. It just didn't have the phone call capabilities, I guess. But as you can see, a lot of that technology costed a lot of money when it came out, and now it's a lot cheaper. Everybody has smartphones. People might not have like nice clothes, but they have a smartphone. You look at really poor places, and they still have a smartphone. Yeah, like I see that all the time. Like if I go to Mexico to like really, really hard hit areas, you will see people that have a smartphone, but they're like homeless at this point, and it's very sad. But it does show that technology is definitely spreading. It just takes time. And so one of the important things that we try to do is to spread technology faster. And things like a Raspberry Pi have allowed places that would normally not have a computer to be able to have power to a computer and power to the internet. And part of that job is the government has to be able to kind of encourage and fund these technologies in developing countries. But at the end of the day, until that happens, there is this digital divide that of people that have ability to access the internet and people that don't. And it's very sad, but it's important to know. And it's not a matter of just throwing money at a problem, because some of these places don't have the infrastructure to be able to even run a computer. They may not have constant power. They may not have actual internet like line. So even though they had a computer, they would have no way to connect unless they had like satellite internet or something, and then like a solar panel power battery system or something. So a lot of people are actively working to shrink this digital divide, but sometimes it's about culture. Some people may not want to have technology, and at that point you have to respect what they choose. But at the same time, some of them that do want can't have it because they don't even know that it exists out there. And of course, this creates social inequality. So that's another problem, that people with computers may have an advantage that just keeps growing more and more. And as we saw with the last lecture, computers can cause unemployment when jobs are taken by like manufacturing jobs are taken, right? But as we saw, then these people have to go to different areas. But then again, that's easier said than done. On the other hand, another divide is from the social point of view, that computers have been, known to cause social disintegration. In a way, a lot of people allege that they might be dehumanizing, that they weaken communities, and that they encourage an isolated nature. That, the whole like, don't spend all day behind the computer, go out and play with your friends kind of thing. So yes, social media allows us to communicate with people in unprecedented ways, but at the same time, we are removing face-to-face interaction and replacing it with digital interaction. And there's an argument to be made about that, whether it's a good or bad thing. And some people say it doesn't matter, some people say it's bad. So I encourage you to seek information about that and inform yourself. It's not all bad though. The ability to have computers in school have helped to advance knowledge for children that may not have access to an actual computer and to an actual person that is educated in the field. So somebody who is in a very poor area in the world, who may not have an expert who can teach them good math. They don't have a good math teacher, but if they have access to a computer, they can go watch lectures from like MIT on mathematics, and then bam, all of a sudden now they have access to this great knowledge. So that's one of the reasons why people advocate to try to bring technology, bring the internet to these hard-hit communities. Very recently, I guess it's a personal anecdote. Somebody wrote a comment in one of my 219 videos that said that they were watching my videos from like Kenya. And I was like, wow, this is really cool. And he said, like, my classmates are watching them too. And I was like, wow, that's even cooler. So, to have that reach, to be able to help people in places that are more hard, they're more at need for this knowledge, it made me feel pretty happy. And I think we all should do a part to try to help out in that form. So that's why I make my videos available for free on YouTube, so that anybody who wants to seek the knowledge can get the knowledge. But of course, to be able to do that, they need a computer, they need internet access. And that's why it's so important to shrink this social and computer digital divide. So from there, I want to kind of change gears a little bit and talk about the future of AI. And this is a very controversial topic, because you go and watch a movie, you go watch Terminator or The Artificial Intelligence by Spielberg, or just about most computer movies where there's robots. The theme is always the same, that once we have a machine that has self-awareness, that it's going to basically destroy us and it's going to rule the world, and the human race will be the end by these super intelligent humans or intelligent machines, right? I mean, that's the plot of pretty much every Terminator movie and Skynet and all these things. And so, we have to talk about that. The fact of the matter is that at some point in time, and this could happen tomorrow. Actually, no, I highly doubt it'll happen tomorrow. But it can happen in a few years, but it can also take thousands of years. Nobody knows. And if they did, then we would be able to do it. But nobody knows. But there will be a time when we will be able to create artificial intelligence. And the reason why that's possible is not because that we have the technology to do it. When people tell you, machine learning and AI, that's like real artificial intelligence, it's not. At the end of the day, all of the computers that we're using today are based off of binary, zeros and ones and logic gates, and or not. That's it. That's all it is. You cannot create a self-aware consciousness that way, because you would have to pre-program it, and it would not have its own life. It would be pre-programmed, which means you do not have free choice. So that doesn't mean, however, that we can't achieve this some way, because at the end of the day, we humans are made up of the same material the computers are made of, which are atoms. And at some point in time, we are going to be able to reconfigure these atoms to create, if anything, an artificial human that is by all means identical to a human that was born in the womb. When we do that, technically speaking, that would be an example of artificial intelligence. So that will arrive someday. Now, are there other ways to achieve self-awareness? Nobody knows. And that's why I tell you, that while we may not be able to achieve it with computers today, computers of tomorrow might. Now, people might throw in quantum computing. No, that's a whole different thing, unrelated. That is not going to get us any closer to that. Quantum computing is only useful for solving specific type of NP problems that allow us to solve them from NP to P. Think about analysis of algorithms to understand what P versus NP is, like non-deterministic, polynomial, blah, blah, blah. So at the end of the day, though, when it does happen, we kind of have to sit down and say, is this something that we want to do as a society or not? Some people say yes, because the smarter computers get, the closer we get to artificial intelligence, the less work that we have to do and that the machines can do for us, right? But then, of course, the fear is that if and when computers become self-aware, should they get rights like humans do? Should they, like animals do? There's animal rights. There's human rights. There are different tiers between animal and human rights, but they all have rights. Where do machines fall in that category? And so that's an entire course on its own to try to decide that. I just want to bring up that is an ethical question that we're going to have to sit down and decide what we're going to do. At the end of the day, I believe that if we make an artificial intelligence that is superior to humans in any way or form, in every way or form, if they bring upon us the end of the human race, then that's just going to be natural selection. And if it has to be that way, then it has to be that way. Because at the end of the day, the earth is going to end someday. And we need to be able to go and expand life to other parts of the universe. And humans have a limited lifespan that is not very useful for interstellar travel. So if machines can do that, if machines are able to spread life to other places because they can live longer, they can survive interstellar travel, then so be it. And it's just something that we have to accept. Hopefully we get developments that don't require this to be the only way that life can continue after the earth ends, because it will end, but it might happen. So that's kind of what I wanted to bring about with the future of AI, that some people call it the technological singularity, that it means that at some point AI, or a combination of humans and AI, are going to advance so much that we cannot understand or comprehend what lies on the other side. So that's kind of, if you Google that, it's kind of the point where we're like, okay, well, something's going to happen at some point. We don't know what will happen, but it'll happen. And so that doesn't mean that we should be scared about technology. I went ahead and posted a clip of JFK and automation, because it's always been a continuous worry for people, even back in the 60s, that automation was going to replace us, and this and that and that. And I think JFK eloquently put what I think is the best way to look at it, and that is that the whole point of machines is to make the life of humans easier and better. A lot of things that we have today are thanks to automation, and we wouldn't have it otherwise. And so I don't think we should be afraid of machines or AI. We should not be afraid of that. If that's where evolution takes us, then we should just embrace that and accept it. And I think that it's our duty to continue the human race, but also not to limit progress of how life evolves. So I think I'll end it with that part. And now we can talk about the risks of technology. And so with that, what I really want to cover is some failures that we have had in technology, and sort of responsibilities that we have when we're dealing with technology. So as a basic example, let me tell you the story of something known as Terrac 25. So Terrac 25 was a computer-controlled, and I'll post a link to the Wikipedia article on this, but it was a radiation therapy machine to treat cancer. I believe it was to treat cancer, but it was meant to give a limited amount of radiation that would help to hopefully fight. I think it was to fight cancer. It might have been to do X-rays, but I think it was mostly to give like small doses of radiation by doing radiation therapy. Unfortunately, there was a bug in the code that was caused by race condition. If you don't know what race condition is, you learn about it in CS 370, but in the most basic example for concurrent programming is when you have two processes that are working on separate threads. So it means they're both running on the computer, on the CPU. And we have process A and process B. And they have shared memory, which we're going to have a little variable int x in here. Okay? Now, this process and this process both know the location of memory. Let's say that each of them is supposed to increase it by 2. Well, if things go nicely, process A is going to increase the value of int x, which currently has a 5 in it, and it's going to make it a 7. And then process B is going to increase it by 2, and it's going to make it a 9, right? So we get from 5 to 9 because plus 2 and plus 2 is the same thing as plus 4. Okay, well, this is all great and good, but what happens if A and B are trying to increase it at the exact same time? Let's kind of analyze at the atomic processes that happen when you increase a variable. The first thing that you got to do to increase a variable is you need to see what's in the variable, So you copy the 5 to some temporary location in your register. And then you look at that and you're like, okay, I need to add 1 to that. Store the result somewhere temporarily. Might be over here as well. And you do this in your arithmetic logic unit. And then when you finish that, then you go ahead and you overwrite the variable x with whatever you have in your register. You know, call it like EAX register or whatever. Or I don't know, if you're using MIPS, it could be like whatever the mixed registers are, R1 or whatever. And then you go and you put a 6, right? So these are the actual operations that are happening when you increase a variable. The first thing is you take the information, you move it to your local register, you do the ALU operation on it, and then you get the answer to that, and then you copy it back. The problem is this. If I go in here and I take the 5 to increase it by 1, I'm going ahead and I'm doing the increase to 6. 5 plus 1 is 6. And then I'm going to start to send it back. But in the meantime, B comes in and does the same thing. They copy the 5, they increase it by 1, and they get a 6. Okay, now you go back and you change this to a 6. And then because you got to increase it by 2, you take it again. So you take the 6 again, and then you go and you increase it to 7. And you're so fast that you actually already go back here and overwrite this with a 7. And meanwhile, this one's still like doing the +1 there just because it's a little slower or it was busy doing other things. And now it's going to send it back to 6. So it overwrites what's here with a 6. Okay, it still needs to do +1 more, so it takes it. Takes a 6 here, does +1, so it becomes a 7 now. And then eventually brings it back and puts a 7. So then it's like, okay, int x +2 on A and +2 on B is equal to 7. And as you can see, 7 is not equal to 9, right? This is what's known as a race condition, because what happened was that 2 processes were dealing with the same variable at the same time, and so one of the information got lost. Essentially, while this one was trying to write, this one was trying to read, and they all basically overwrote each other. So instead of getting a 9, I actually got a 7 because of that. So as you can see, race condition can be a really bad thing because it can really screw up math. And if this is a critical computation where like somebody's life depends on it, no, the math is wrong. And instead of giving them, 4 seconds of radiation or this much of radiation, I'm going to give them 4 times that amount, right? Well, it turned out that actually the amount that they gave them because of the race condition was sometimes hundreds of times greater than normal. If there's anything you should know about radiation is that it's not good for you. Sometimes it's necessary to do some things like taking an x-ray or doing radiation therapy, but it's not overall good for you when you want to keep the least amount possible. And when something that's supposed to give you a little bit of radiation is giving you hundreds of times more than it should, people die. And they did. People died because of this, or they had serious injuries or burns. They were getting enough radiation to basically kill them. So, unfortunately, it took years before they actually discovered what was happening. And people died because of this. So eventually, of course, somebody went ahead and they did an investigation. The FDA were like, yo, something is wrong with this. And other organizations were like, there's something really messed up with this. And so they went ahead and they did an investigation. And again, they found out that it was a race condition and that it was a software problem. That, as Wikipedia says, when the operator incorrectly selected X-ray mode before quickly changing to electron mode, which allowed the electron beam to be set for the X-ray mode without the X-ray target being in place, a second fault allowed the electron beam to activate during the field light mode, during which no beam scanner was active or target was in place. In other words, when you were doing 2 things at the same time very close to each other, it actually created a race condition which basically screwed up the configuration of the machine and started shooting radiation, just randomly shooting radiation out there. So apparently some people actually said that they felt an intense electric shock when they were hit by the radiation, and then they started getting radiation bumps and poisoning. So they were like, okay, so there's a software problem. So how did this software problem actually get into production? And so they started doing an investigation, and they found out that the people that coded this software was not independently reviewed by anybody. They basically just trusted the coders to get it right the first time, and then let them test their own code and then publish it. There was no external review, no form of real code review or quality assessment or things like that. On the other hand, in the CS department, we tell you like, hey, plan out your code before you start. Like, do your algorithm, make a game plan, and then go and code. Don't just start coding from the beginning. Well, the reason we tell you that is because of things like this. Turns out that these people, when they coded this, they just kind of coded it from the get-go. They didn't have a real plan set up. And because they didn't have a plan set up, it was never assessed by other people, which would have detected the error ahead of time. So they just kind of coded it as it went, probably patched it as it went, and said, hey, it compiled. Let's go ahead and put it on production on this Friday afternoon and go have a nice dinner. So that's pretty much what happened. And of course, people paid the price for that. And that's kind of the really sad part. So this, the reason I tell you this story is because we have a responsibility as programmers, developers, to the code that we write. Because sometimes if we're writing code that's just for a video game, okay, the game crashes, big deal, end of the day. But even in the video game, hey, if the bug that we cause makes people lose real money, there's a monetary cost to this. But okay, monetary cost, money can be replaced, but life cannot. If you're working on something that is life critical, like life support system, something that involves something dangerous like radiation, or hey, if you're working for the Iranians on those centrifuges, or if you're working on something like an air traffic, autopilot, these are things that lives people depend on it, or something like a power grid. These are all things that are mission critical. And so those are the kind of programs that you want to make sure that you actually are very, very careful on, and that you have external reviews and other things. You have a responsibility to make sure that the code works. So how do you do that? Well, there's, in case of developers, there's of course external reviews. There's planning stage before you actually start coding. Once you're coding something, you can also do unit testing, where you can basically, guarantee that. The good thing about unit testing is that when you change code with an update, you can retest it to make sure that everything is still working fine by having asserts and unit tests, right? So that's kind of the risk with technology that I'm talking about. That that people's lives may depend on your code, and it's something that you cannot take for granted. And it is important, remember the quote, those that do not know history are deemed to repeat it. And so it's very important to study errors that have, caused things like this, race condition, so that you don't repeat those errors in any case, whether it's life critical or not, but especially in life critical stuff. And so it turns out that actually you can go to jail, because if you're coding for something that has life support and you are found to be negligent and to not have been careful with your code, and somebody gets hurt over it because if it's in the hospital or something, you are responsible for it and you can go to jail. So if anything, at least do it because you don't want to end up in jail. And so like this, there's been other cases that I want to talk about. So first of all, why does this happen? You might be thinking, well, I'm going to check all my code. Well, when you take Automata and you learn a little bit about computational theory and automata and all these things, you are going to learn about something known as the graders problem. And in short, what the graders problem is that if I, as a person that teaches programming courses to my CS 202 or 135, suppose that I wanted to write a program that could verify somebody else's code. It's possible that I could do that. However, it's not going to always be correct, because it's been proven for a long time. And again, I'll let them talk about it. I do have a video on this that I did as a bonus in Trello too, but I don't want to go too off topic here. But it's been proven that it is impossible for you to write a simple program that can check all possible combinations of code and merely say whether the program will terminate or not. And by that I'm saying, if you write a piece of code and I ask you, is that code going to run in an infinite loop or is it going to terminate? You might be able to answer that for your specific code, but it's impossible for you to write a program that can check every possible combination of code and come back and tell you whether it's the case or not. And so what that tells me is the same problem that we face here, that most computer applications are far too complex and virtually impossible to produce a program that has no errors. It is impossible in some cases. Infeasible, I think is a better word. It's infeasible to do it. And so that is why when you're writing software that is more critical, it is your responsibility to try your best. But even then, you might miss something. But you want to make that chance to be much, much less than it has to be. And so failures can be more than one factor. I mean, you could have a solar flare that just breaks your computer and then that's over. You know, no matter how good you code, if the solar flare changes a bit from 0 to 1 and the whole thing breaks because of that, that's beyond your hands. But you have a responsibility to study failures, learn to avoid them, and understand that the impacts of your work can be far-reaching. Some cases that I have here listed that I wanted to also list of examples is, for example, voting systems, right? Voting systems are vulnerable if they're electronic to viruses or hackers, technical failures and things like that. So this has happened in some places. I don't think it's, well, I don't know. It might have happened in the US. Who knows? But I know it's happening in other places. But, those are examples of things that you have to be careful of. Another example that happened was actually in Denver Airport. There was a baggage system that failed due to real world problems. And when they did the investigation, it found out that the main reasons why this happened was because there were significant changes in the specs of what the project was after it started. And so if you are developing software and then your boss comes in halfway and says, oh, by the way, we need to change this and this and this and that to different requirements, you have a responsibility to make sure that if you don't feel comfortable doing those changes and adequately testing them, that you tell somebody about that. And yes, sometimes we're pressured to the point that people will say, if you don't get it done, you're going to get fired. But you need to make sure that if something is not done right, that you still speak up, because if you do it, but you don't, because you don't want to get fired, but then lives get lost. Getting fired would have been the least of your concerns at that point. And this is what happened with the DIA, Denver Airport, that in addition to changing the specs halfway through, the allowed time for development was insufficient, which was the main cost for the baggage problem that they had. Other examples I have here are airports in Hong Kong and Kuala Lumpur. Comprehensive systems there failed because they did not detect for the classical user input error. So, one of the things that they teach you when you're coding is that you want to sanitize your input. And what that means is that you want to clean up any sort of user input to a program to make sure that they don't write things that could crash the program, such as invalid characters or strings that are too long or SQL injection, things like that. And so it turned out that in these airports, they were not careful enough for that. Somebody put in one too many keys and then the whole thing crashed. Other systems or failures that I have here are, there has been cases where some system flaws are so bad that at that point they just stop using the program and they make a new one because it's just too much effort to fix it. And this costs a lot. I mean, they're wasted millions of dollars on things like this before. So overall, what all of these examples show you are a couple of bullet points that I want to emphasize. And that is, you need to have specs before you start coding. You need to have well thought out goals, because if you have lack of clear, well thought out goals and specifications, problems happen there. You also need to have good management. If you have poor management and poor communication amongst the customers, the programmers, the designers, problems come up with that. When you have institutional or political pressures that encourage unrealistically low bids, if you're bidding for being able to develop a system for the government, you obviously want to be the lowest bidder so that you get accepted, right? But there's a difference between being a low bidder and being an unrealistically low bidder, where you're bidding far below what you actually could achieve, which ends up actually underestimating what you need to do and ends up with a half-done job that has problems, right? So management is very important. Also, we all think that new technology is amazing and we all want to use the latest programming languages and the latest tools. But the problem with something new is that, yes, it's cool, but it's also untested and potentially unknown if it's reliable or not. Problems may arise that may not have been discovered yet. So a lot of the times, a lot of these examples that I told you, they were trying to use new technology, which at the end of the day ended up causing more problems than it solved. So instead, I highly encourage you to use tested technology. Don't use the latest version of Python. Go ahead and use a little previous than that you know is tested. Don't go with the latest version of Ubuntu. Go a little far back. Those kind of basic things. But finally, and most importantly, one of the major issues that these sort of situations share is that people refuse to admit when a project is in trouble. People don't like saying I screwed up. People don't like apologizing. And this causes problems because if something is wrong, if you screwed up, you need to go and admit it and work from there. But if you don't, because of pressure, again, this is when problems happen and people die. Other things are that are always a pain are legacy stuff. So like older programs that we're trying to support. We got things that are still running on like Fortran and all these old languages, and nobody knows how to actually use them anymore. So trying to keep them safe is a pain. And then there's like no documentation, and they're expensive to replace, and they're reliable, but they're not flexible at all because it was coded 50 years ago. So that is also another issue that tends to happen. That it's a ticking time bomb at the end of the day. So yeah. When it comes to errors in computers, some of the common factors that we see with that is inadequate attention. Well, first of all, the design and development problems that we see. And those design and development problems that we see are things like carelessness, inadequate attention to potential safety risks, interaction with physical devices that don't work as expected, confusing user interfaces, incompatibility with certain hardware or software or with certain OSs, not planning for specific or unexpected user input, like I was saying, with not sanitizing your input, insufficient testing, overconfidence in your own skills or the software that you're working on, and trying to reuse other software without adequately understanding or checking it, aka going on Stack Overflow and downloading an implementation that you don't even know if it's right, and if you tested it once and it seemed to work, then you just kind of call it a day on that. That's a no-go. What else do I want to say? I had some notes about the ThreatAct 25 that apparently that they had, which was like they confused microqueries with milliqueries, which was a big deal. But I think I've already talked enough about that. So the last thing I want to mention are some advices, again, on the same, call them professional techniques. And those are things like you should always add redundancies and self-checking to your code. Always test your code and include real-world testing with real-world users, which means don't just try to test it with other developers. Give it to people that have no idea what they're doing, who are like the real-world users would, and make them testing when you have a quality team. I was reading actually about Microsoft was has quality testers for their store site, and so what they do is they just hire random people with no programming skills. They just random people, and their job is just to place orders for a bunch of things. And there's a flag in the system to basically not ship out the orders, and they give them fake credit card numbers that are like just going to work in the system, but they're not placing real orders, right? And the idea is to make sure that everything works, and that if these people find a bug, it's because they're not tech people. They just want to place orders and see if there's something that they break. And so they have a bunch of these, and it turned out one of them decided to try to buy a gift card. And whereas physical items would not be shipped because, again, it was a test account, it turned out that digital items were released. So when you order a digital gift card, the code that he got from the digital gift card actually worked, and it was real money. And so what did the person do? Well, he was like, I wonder if this works. He tried it, and boom, it worked. So he went ahead and bought a Microsoft Office with the gift card value. And he was like, wow, this works. So he went ahead and bought a couple of graphic cards with that. And he was like, wow, they actually shipped these. And that's when he got pretty ambitious and was like, well, I can keep buying as many of these as I want. And so what did he do? He bought 10 million worth of gift cards. And then he started selling them at a cheaper price so people would buy them, a discount price. And he made over $2.something million, like $2.5 or $2.4 million. It took some time, but of course, while he probably would have gotten away if all he did was buy the Office and the graphic card, when there's millions of dollars involved, then people are going to investigate. And they did eventually track him down, and I think he's serving 9 years in Yale and is supposed to pay back like $8 million worth of like restitution or whatever they call it. So yeah, interesting story. But why did this happen? Well, the tester actually found the bug, but he didn't report it. What did he do? He tried to profit. So while yes, you should always include real world users when you're testing, make sure that they are also going to be reliable and will actually tell you when there's an exploit rather than actually using that exploit for their own profit. Fortunately, the story happy ending, guy's in jail and the bug is fixed. But, the testing program. So in this case, it wasn't even the shop that was broken. It was the testing program that was broken. The testing program introduced the vulnerability here. So there you go. Interesting story. I think one of the important things that we should also point out is always avoid complacency. It's very easy to get complacent that something works. You don't need to test it. It's good to go. That it's all good, and then bam, everything is great until it's not, right? And that's what you want to avoid. Don't get complacent. Always make sure that you convince yourself that something works and that you have the testing capabilities and that you have clear and well-defined specifications and that your user interfaces are clear, instructions and clear error messages, that they're consistent, that they have things like an appropriate checking of your input, sanitize your input to avoid errors. Like I say that so much because it's one of the most basic things, and yet it's one of the most basic things that people still forget. So yes, and as always, this is easier said than done, but a workload that is too high for someone is dangerous because that's when they start cutting corners. So you have to be very careful about that. Always have redundancy. Always have some sort of self-checking. Always have verification, validation. And with verification, I suppose, very important to have what's known as IVNV, which is independent verification and validation. That means, in the most basic sense, it means let your neighbor look at your code. Well, don't do that in school because that would be cheating. But I'm saying when you're developing, let somebody else with a fresh set of eyes look at your code and make sure it works. What it means in an actual real-world application is hire an independent company to verify and validate your code when it's something life critical. Okay? And we'll have things like beta tests, alpha tests. You always want to have this kind of testing as well. And I think that's it. That's all I wanted to talk about. A lot of preaching. But it's important. at the end of the day, this is an ethics class, and there's also social implications, right? Don't become the next case study. Don't become the next Derek 25 or the next Denver airport. Do not. You should solve problems and make the world a better place. Don't introduce problems and make the world a riskier place. I joke sometimes, and I know other of my colleagues joke, like when we look at somebody's coding, we're like, oh man, I hope that he's not coding the next autopilot that I'm gonna, in my planes, and we all joke about it. But the fact of the matter is that, be responsible when you're coding. It's not a game anymore when you're out in the real world. People's lives may depend on it if you're coding something mission critical, and always speak up and do the right thing. And as long as you do the right thing, things will work out. I strongly believe that. And with that, I thank you for watching, and I hope you have a wonderful and safe day. Take care, everybody.